Hello everyone, welcome back to I Am Technos. In today's video, we are diving into AWS Systems Manager Parameter Store. This video will guide you through the essentials of Parameter Store, from understanding its core features to a hands-on demo. Today's agenda is simple. We will start with an introduction to Parameter Store, then explore its key features, followed by a hands-on demo, and finish with best practices. Let's get started. Before we talk about the Parameter Store, let's understand what a parameter is. Parameter is any piece of data, such as a block of text, a list of names, a password, AMI ID, a license key, and so on. Parameter store is used to store these parameters. So what is a parameter store? Firstly, it's a key capability within AWS Systems Manager. It's primarily used for securely storing both the configuration data and secrets, collectively referred as parameters. You can store parameters in two ways, either as a plain text or as encrypted data for enhanced security. Additionally, you can reference these parameters in your scripts, commands, and Systems Manager documents. A parameter example is shown here, consisting of a parameter name and its corresponding value. Now that we have explored what Systems Manager Parameter Store is and why it's essential, let's take a closer look at its key features. First up, receive change alerts. Imagine you stored your database password securely in AWS Parameter Store. You can create a rule in Event Bridge to capture any changes in the parameter store. You can set the SNS topic to send an email or any other form of notification to alert the appropriate users. So when a change occurs to a database password, you will receive an email with details about the change. This gives a visibility and better control over the system's configuration. Next, we have organized parameters. If you have parameters related to a database, such as database password, host, and port, you can effectively organize and identify them using tags. Tags allow you to group and manage parameters based on specific attributes, such as environments, departments, or purposes. And then we have label versions. Imagine you are working with a parameter called database password. And over time, you have created multiple versions due to various updates. After a while, it can become challenging to remember why these versions were created or what each one represents. That's where labeling versions come in handy. With labels, you can assign a meaningful alias to specific parameter versions to make them easier to manage and identify. For example, for V1, you can add initial password for development. For V2, it's a password updated for staging environments. And for V3, password updated for production. Next, we have a built-in data validation. This ensures parameters meet specific requirements like correct formats or constraints before they are saved. Let's look at this example. Imagine you are storing AMI IDs as parameters. You have created three parameters. The first parameter is correct. It's a valid AMI. The second and third parameters are invalid because AMI IDs cannot contain underscores. And AMI IDs must begin with AMI, not AM1. So AWS Parameter Store will not allow the creation of the parameters with invalid AMI IDs. If you attempt to save an invalid value, it won't be created. Additionally, you can use CloudWatch to view the logs and identify the reason why the invalid parameters weren't created. This helps to reduce errors and maintain the integrity of your data by preventing invalid inputs. And then we have cross-account parameter sharing. This is helpful for scenarios where multiple AWS accounts need to access the same configuration data. In this example, account A will securely share a parameter with account B. To securely share resources across AWS account, IAM roles are used to grant the necessary permissions. In this case, account A's IAM policy allows account B's role to access the parameter. Additionally, CloudWatch can be employed to monitor and log cross-account activities, providing insight into who is accessing the shared resources and when. Parameters can be accessible from other services. Imagine your Lambda function need to access a configuration value such as an API key stored in AWS Systems Manager parameter store. Lambda makes an API call to the parameter store. Parameter store verifies if Lambda IAM has the required permissions like SSM get parameter permissions. If allowed, the parameter value is securely returned to the Lambda. It's not just Lambda, other services like EC2, ECS, and even step functions can also access parameter store using their respective IAM roles. Seamless integration with AWS services. In this example, parameter store can be integrated with AWS KMS, key management service. We store the API key in parameter store and AWS KMS encrypts the key, transforming it to an unreadable format. The encrypted key is securely stored in the parameter store and can only be decrypted and accessed by authorized services, ensuring our API key remains protected. Now that we have covered the key features of AWS Systems Manager parameter store, let's move on to the hands-on demo. In this demo, we will explore how to securely retrieve a database URL stored in AWS Systems Manager parameter store and access it from an EC2 instance. We will begin by creating a parameter in the parameter store to securely store our database URL. Next, we will launch an EC2 instance, assign the necessary permissions by attaching an IAM role. Finally, we will fetch the parameter value by connecting to an instance by storing it in a file. To get started, ensure you have an active AWS account. You will need EC2 permissions to manage instances and assign IAM roles. Additionally, make sure you have IAM permissions to create roles with Systems Manager access. Finally, confirm that you have necessary permissions to manage parameters in the AWS Systems Manager parameter store. So log in into your AWS Management Console. We will be doing our hands-on in North Virginia region. The first step is to create a parameter in the parameter store. In the search bar, type Systems Manager and select it. You will be directed to the Systems Manager dashboard. In the left side navigation, under Application Tools, select Parameter Store. Click Create Parameter. Set the name to something like dev app DB URL and optional description as database URL for the development environment. You can choose between two tiers, standard and advanced. Standard tier is free and stores up to 4 KB per parameter. You can create up to 10,000 parameters for each region in an AWS account. Standard parameters doesn't support parameter policies, such as setting an expiration for a parameter, and you cannot share your parameters with other AWS accounts. On the other hand, advanced tier is charged based on usage with a cost per parameter stored. You can store up to 8 KB per parameter and can create up to 100,000, like 1 lakh parameters. The advanced tier does support the parameter policies, allowing you to set an expiration for a parameter, and you can share your parameter with other AWS accounts. For this demo, we will stick with the standard tier. In both standard and advanced tiers, you can choose from 3 parameter types based on your use case. Let's understand them. String stores plain text data, suitable for non-sensitive data like configuration settings, URLs, or general strings. For example, you can store true or false, or a URL like https api.example.com. Okay. You can also choose AWS EC2 image to store AMI IDs. Next, we have string list. It stores comma-separated list of strings. It's best for scenarios requiring multiple related values stored in a single parameter. For example, a list of security groups separated by commas, or multiple URLs or resource identifiers. And lastly, secure string. It encrypts sensitive data using KMS, a key management service. It's ideal for storing confidential information like API keys, passwords, or secrets, and it requires appropriate IAM permissions for access. Okay. For this example, we will select a string, data type as text, and value as pasted. Okay, it's a simple database URL. You can optionally add tags to your parameter for easier configuration and management. For example, you can say key as database and value as MySQL. So click create parameter to store it securely. Once a parameter is created, you can select it to view its details. The details include the parameters ARN, the last modified user, which is root here, the modification date, and the current version. If there are multiple versions, you can view them under the history tab. Currently, I have only one version. However, let me show you a parameter I created in another region that has multiple versions. So select the parameter and go to history tab. So here you can see 3 versions which are created. Moreover, you can assign labels to these versions, such as, for example, for the version 1, you can add initial, and just refresh it to reflect the changes. Testing for V2. And staging for V3. Okay, this way we can track their purpose or stage. Next, let's talk about tags. Tags are different from labels. Tags are associated with the parameter itself, whereas labels are applied to specific versions of the parameter value. This distinction allows for better organization and management of parameters and their versions. You can edit a parameter to update its description, tier, or even value, which will generate a new version. For example, if I currently have 3 versions and want to create a 4th version, I can simply edit the parameter, enter a new value, and save it. So this action creates a new version which will appear in the history tab as the latest version. And you can add a label as production. Which will reflect here. Now let me show you a parameter created with the advanced tier. Okay. The key difference is the ability to set parameter expiration policies, which you can manage in the policies tab. Additionally, the sharing the tab allows you to share the parameters with other AWS accounts, a feature not available in the standard tier. However, please note that these parameters created with advanced tier incur charges based on usage. If you want to avoid additional cost, it is advisable to stick with the standard tier unless you specifically need the advanced features. The last feature I wanted to highlight in parameter store before we move on creating an EC2 instance is the parameter store default tier found in the settings tab. Okay, so this is the one. When creating a parameter using CLI or SDK, not through console, okay? Specifying the parameter tier is optional. If you don't explicitly define a tier, the system will use the default tier set in the settings tab. If the default tier is standard, any parameters created via CLI or SDK without specifying a tier will automatically be categorized as standard. If the default tier is advanced, parameters will be created under the advanced tier by default. However, if you select the intelligent tiering, The system will automatically assign the appropriate tier, either standard or advanced, based on parameter characteristics. For example, if you set intelligent tiering as a default tier and create a parameter with a value size within 4 KB, no policies and no sharing requirements, it automatically be added to the standard tier. If the parameter exceeds 4 KB up to 8 KB, includes policies or requires sharing capabilities, it will be categorized under the advanced tier. So based on your inputs, intelligent tiering will intelligently associate your parameter with either the standard or advanced tier. Now let's return to the parameter we created in North Virginia region. As per the architecture, we have created a parameter in the parameter store. Now let's create an EC2 instance with an IAM role that has necessary permissions to fetch the parameter. First, go to IAM dashboard in the AWS Management Console. In the left navigation panel, click on Roles. Click a Create Role. In the Select Trusted Entity, choose AWS Service. Under Use Case, select EC2 as a service that will use this role. Click Next. In the Add Permissions, search for Amazon SSM Read-Only Access. Amazon SSM Read-Only Access. Select the checkbox next to this policy. Click Next. Give your role a meaningful name such as EC2 Parameter Store Access Role. And optionally, add a description such as EC2 instances read-only access to AWS Systems Manager Parameter Store. Review the permissions and click Create Role. Now that the role is created, go to EC2 dashboard. In the left navigation, select Instances and click Launch Instances. Under Names and Tags, give the instance a name such as Fetch DB Parameter Instance. Choose Amazon Linux to AMI. Select T2 Micro as an instance type, which is under free tier. Choose Proceed without a key pair, since you are not using a key pair for SSH access. Under Security Group, ensure that SSH is enabled to allow access to the instance. In the Advanced Details, select the recently created IAM role from the Instance Profile dropdown. Scroll down to the user data section at the bottom of the page. Paste the user data script. Let me maximize it for you. The first line is called shebang, and it tells the system to use a bash shell to execute the script. It is a standard practice to include this line at the top of the shell scripts. Yum update -y. This command updates the system packages. The -y flag automatically answers yes to any prompts, ensuring that the update completes without user interaction. It keeps the system packages up to date for security and stability. And this is a comment. Comments in shell script start with hash symbol and are ignored during the execution. The comments doesn't execute. And this command basically fetches a parameter from the AWS Systems Manager Parameter Store and assigns its value to a variable called db_URL. And there is another comment. And the last line writes the value of the DB URL into a text file. Okay, so whatever the output of the echo will be stored into the DB config file, which is stored in the home EC2 user directory. So when the script runs, it retrieves the parameter value from the parameter store and assigns to a variable. And then it writes that value into the DB config file. So after pasting the user data script, click on Launch Instance to create the EC2 instance. You can now connect to this EC2 instance via EC2 Instance Connect or SSH if you have a key pair. So select the instance, click on Connect, and under Instance Connect, click Connect again. Let me maximize this screen as well. Now check the current directory using PWD, which stands for present working directory. Ensure it is a home underscore EC2 user directory to access the DB file. Run ls to list the files in this directory. You should be seeing dbconfig.txt. Use cat dbconfig.txt to display the contents of the file. This confirms the EC2 instance successfully fetched the parameter value from the parameter store as per the architecture. Once done, clean up the resources, terminate the EC2 instance. Select the instance state, click on terminate it, confirm it. Delete the parameter from the parameter store. So go to parameter store, select the parameter, click on delete. And remove the associated IAM role. Search for EC2 parameter store role, select it and delete it by copying the role name. Okay, so it's successfully deleted. To conclude, here are some of the best practices to keep it in mind when using AWS Systems Manager parameter store. Store sensitive information like passwords and API keys using secure string parameter type with KMS encryption. Use fine-grained AWS IAM policies to restrict access to specific parameters. Assign tags to parameters to simplify tracking, billing, and identification. Track parameter access and changes using AWS CloudTrail to maintain compliance. Set expiration policies for parameters to prevent stale or outdated configuration. That concludes our hands-on session for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.